What if everything we think we know about life is wrong? Could redefining life change the way we explore the universe? What is up, everyone? My name is Ishaan, and welcome to the video. I'm a PhD graduate student at Purdue, but I should mention that none of these things actually reflect Purdue's opinions or anything like that. Like, this is just me making my videos and tackling some of the big questions in science. My personal interests include learning about the universe through different perspectives, through different sciences, looking at it from different lenses, thinking about the origins of life, how life came to be on Earth, how we can find life in other places, and advancing human space exploration. Like, these are some of the big ideas that I like to work under. And today we're going to tackle the big question: what is life, and do we need a new definition to guide us? Let's start with how we currently define life, which is set by NASA's definition, of course. Life is a self-sustaining chemical system capable of Darwinian evolution. This is the simplest definition. This is the one sentence definition that the astrobiology community agrees to and follows when we're talking about life in scientific papers and in like discussions or whatever. But this small sentence has so much weight to it that I think we need to break it down word by word as to what it's saying. Life is a self-sustaining. Self-sustaining, what does that mean? Energy use, growth, repair mechanism. It's basically referring to the ability to be able to maintain an internal environment regardless of what's going on in the external environment and without external intervention. So I think this also includes being able to hold your internal environment despite external changes, which is the basis of homeostasis and how our cells usually function in biology. Self-sustaining chemical system. Chemical system. Why emphasize chemistry? I think this focuses on the fundamental role of chemical reactions and molecules in sustaining life as we understand it, and how it came to be on the early Earth, where chemistry transitioned into biology. And this class of chemistry we refer to as prebiotic chemistry, which means prebiotic, which is before life. Biotic refers to anything that's life, pre refers to before, so prebiotic means anything leading up to life. But does this exclude non-chemical life forms, such as, purely digital or quantum-based entities? Could there be forms of life that operate on entirely different principles? I don't know, dude. Lastly, Darwinian evolution. Chemical system capable of Darwinian evolution, which refers to the process by which organisms change over time through natural selection and survival of the fittest, blah, 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 basic Darwinian things. But all of this is really heavily rooted in our current understanding and the sole example of life that we have on Earth, which places certain boundaries, right? Inherently, the definition has Earth-centric bias in it, where when we're studying the requirements of life, there's three basic ones that the astrobiology community has agreed to. First, a liquid solvent. Second, a chemical inventory of the most important elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These are dubbed in an acronym called SNOPS. And then lastly, energy sources, so sunlight, chemical gradients, etc. And there's an emphasis on carbon-based chemistry and liquid water because that's the example of life that we have for the most part here on Earth. And at the same time, this definition is assuming that Darwinian evolution is universal. But what if there is life without natural selection? What if there's not as much competition as we think because there's an abundance of resources at some place? I don't know. I'll have to think a little bit more deeply about Darwinian evolution part. More, another topic for another video. But all of this really ties into the bigger question of, could we be missing life forms that don't fit neatly into this definition? And that's where something called the shadow biosphere comes in. Read up on that if you're interested, but another topic for another video. There really is a distinction between life as we know it and life as we don't know it in the community, but I think for the most part, a lot of the work is focused on life as we know it, and inherently all of our life as we don't know it stuff also has some biases that result from life as we know it. I know, complicated, but at the end of the day, I think studying both sides gives us more insights about the other. Like it's interconnected for sure. But this video we're focusing just on life as we know it, and let's talk a little bit about the two theories that we have for origins of life and how life came to be on the early Earth. We think hydrothermal vents and deep sea vents could have been a potential haven for early life, like early microbes. And if you don't know what hydrothermal vents are, they're basically these systems in seas or oceans where geothermically heated water, it's like cycling through into the ocean, and it's creating this like it seeps in from underneath the crust and coming out, and it creates this gradient of hot and cold water, but it also has a lot of chemistry involved because that water is taking in a lot of chemicals from underneath the Earth's crust and bringing it into the ocean. And I've probably made I've made a video about this before as well. But more, and we can make a more expansive or a more expanded version of this if needed, so let me know in the comments below if this is a topic you want to explore further. But hydrothermal vents are one of the places where we think life could have emerged. Another place is small warm ponds on the surface where the building blocks of life could have polymerized and then transitioned from prebiotic chemistry to biology for simple structures. But like I said, dude, everything, we have these theories, but there's no entirely set consensus on how did life really begin. Did it arise multiple times in these like different locations and then somehow like, I don't know, commingle, like met at some point? Or did it just arise in sporadic locations and then somehow evolve differently? Or are we really missing key pieces of the puzzle that we just haven't considered yet? Everything we know is based on life as we know it. But there can be life that we don't know about. There could be life that exists without water or without carbon or even without chemistry. I wasn't gonna bring this up, but like think about AI and artificial intelligence. You know, is that something that can be considered life? Based on this definition, probably not. But I'm saving this for another video. But I have this crazy idea in my head that AI is some sort of technological life that we've created. We've like artificially created this life form, but it is in some way life, and I can talk about why that is in another video. But this distinction of life as we know it and life as we don't know it, I think this is where science and creativity really collide and open up an entirety of like literally an alternate universe of possibilities. Maybe life doesn't need a new definition. Maybe we just need to embrace the infinite ways that it could exist. But I want to wrap it up here. What do you think? We need a new definition of life, or should we just rethink how we're searching for it? Let me know in the comments below, and if you enjoyed the video, like and subscribe if you want. I'll continue to make on more conversational style videos like these and talk about some of the complex topics. The goal isn't necessarily to teach science, it's to use fundamental concepts and talk about the mysteries of the universe, life on Earth, life beyond Earth, and advancing human space exploration. Anyways, I'll catch you all in the next video.